Good morning, students. This is the next class in the third chapter, trigonometric function. This is the very important and fundamental concept for the now your next chapters are okay, sir. Next chapters are next classes. And this is the fundamental base for the next concept was that whole trigonometric functions and even for the calculus and algebra, many mathematical areas. Circular function, we call it circular function. Circular function of a real number or trigonometric function of the real number means it depends on the how the angle behaves with respect to the curve or how the curve behaves with respect to angle. Okay, students. In previous classes we know for any arc, okay, this is a circle of radius r, length l and theta in radian. We know the relation between theta, r and relation like that, okay. L is equal to r times theta. L is equal to r times theta. This is the concept, here we have the value of theta. You have the two parameters, then you will get the third parameter. There are three variables, three parameters. If you know the two values of the parameter, then third you can be figure it out, can be find it out. Okay. Similarly, let's consider if r is equal to 1, a unit circle. If r is equal to 1, this is the 1 unit circle. Then I am considering this is as x. See here, if r is equal to 1, L becomes theta. This is the fundamental concept. This trigonometry starts here. This is the length. How the length of the arc behaves with the theta. The value of the theta changes. This becomes L becomes theta. That's x. Here x is a real number. The fundamental concept is that you can take the any values. F you can take in pi. You can take okay sir 0.0001 degrees. So you can take x equal to root 2. You can take x is equal to 2 to the power 10. Whatever any values, any real number you can take. Similarly, the same corresponding value you will get the same arc length. Corresponding arc length. So you will get that one. This one, okay. Therefore, the unit circle. So this is called unit circle. Very important. R is equal to 1 and R is equal to 1. This is called unit circle where radius is equal to 1 unit. Unit circle concept. Here L, theta becomes x and L becomes x, okay sir, okay. L becomes also x and theta becomes also x, sir, okay. Here we are taking the theta any value, random value, therefore L also becomes x because L is equal to theta. L is equal to theta. This is the base. So from this onwards, we are going to define the remaining trigonometric values. Okay. Here now we are going to start the trigonometric values. See, and here this is the positive theta and same this will be negative x. If you consider, and this becomes also okay sir, x also same. only that is the only for the sign purpose only. So you will get the this is also, but arc will never be in a negative length. Okay. Okay. This becomes x only. Okay, the value of x. Next is, let's define the sine of angle here. Take the sine of the angle. Same concept in trigonometry, you know. This is the right angle triangle. This is the theta Rx. And this is the B. This is A. And this is C. Just I am defining the trigonometric function. The sine theta. Sine theta is equal to what is that? B by C. Opposite by hypotenuse. Similarly, cos theta is equal to V over C. Is it? This also you can write C into sin theta is equal to B. C into cos theta is equal to A. Okay. This concept I am going to use here. Okay. Similarly, consider the unit circle. Unit circle of radius 1. Okay, this is 1, this is 1, this is A, this is point 1 and 0, this is the point somewhere else A and B in between. Okay sir, this is the point. Okay, I will write take the axis also. This is the y axis, this is the y dash, the x, this is the x dash. Okay, this is the unit circle, concept of the unit circle. Okay. Here, then how to define the sine? Very important. So this is making an x. This is also making an. So this becomes also x. Then we want the point values of B and A. This is the Cartesian points. Cartesian points, you call point, single point, somewhere else. This is the line. Sin x here, if you want to confusion, I will draw somewhere else. Okay, sir. So this becomes, okay, sir. This becomes A, this becomes A, and this becomes B. Point. Means I am taking considering x here, and again value of considering the y here. That's why I am getting the point. This is the value of x. This is the value of x. This is the value of y. Okay, correctly. And means, okay sir, this is the value of B. If you consider this is the value of B and this is the value of A. Here I am going to define the sin theta, sin x. How is sin x? Sin x is equal to what is that? B by 1 opposite by hypotenuse. Therefore sin x is equal to B. Similarly, for cos x is equal to A. These two are fundamental concepts. Fundamental concepts in the trigonometry. Fundamental concepts in the trigonometry. All x belongs to R. All x belongs to R. X is defined for the all values of a real number. This is the concept. You know, and already in previous class, you know, what the first quadrant, what are the values of first quadrant, second quadrant, third quadrant, fourth quadrant. Let's see the values of the different values in the this sin x and cos x. Okay. They give us some sin x is 0, pi by 2. Let's take this one. This one. This is also not necessary. Take the quadrants. Okay, this is the x-axis and this is the y-axis, this is the x-axis, and this is the unit circle of radius 1. This is the x. This is the point PAB. This is A 1 0. This is the B 0 1. So y has 1 in it and x has 0 in it. The origin. This is the O, where value each has 0 0. This is the value C. This is the -1 0, because it's the x dash. This is the x. This is the positive value. This is the negative value. And similarly, this is the y. This is the y dash. This is the negative value. This is the positive value or positive side. Similarly, okay. And take this one. Let's take the value of 0. Okay. Value of sin x and cos x at 0. Value of sin x and cos x at 0. Okay, sir. If x is equal to 0. Okay. For 0. Here we do not have any values. Okay, sir. 0 means this becomes 1. Okay, sir. Here the b becomes 0. Okay, sir. Therefore, sin of x is equal to b by, okay, directly connecting b implies that sin of 0 is equal to b is also 0. Is it? First concept is very important. Second concept. Okay. What is the second value? Second value they given. Let's take the cos x. Hello. Okay. Pi by 2. Next, x is equal to pi by 2. This is the value pi by 2. This is pi by 2 plus pi by 2. This is the pi. This is the 2 pi by 3. This is the 2 pi or minus pi. Similarly, x is equal to pi by 2. So sin of pi by 2 is equal to, this see, sin of p, x becomes, okay, sir. X is moving left side, okay, sir, anti-clockwise side, and this becomes completely 90 degree here. So this line, okay, sir, this line comes here and makes parallel with, okay, sir, makes overlap, okay, sir. What you called syncs, okay, syncs with this one. So if it's already unit circle, so this becomes 1. So b becomes 1 here. Okay, sir. B becomes 1 here. Therefore, implies that b is equal to 1. Okay, sir. B is equal to 0. Implies b is equal to 1. Then this one. Therefore, sin of pi by 2 is equal to value 1. Okay, sir. Second, x is equal to pi. X is equal to pi. Implies that, but therefore b is equal to again 0. Again, this is the b. Okay, sir. This is the b. Comes, makes 0. This is the b. So therefore, sine of pi is equal to 0. Corresponding value. Next, consider the value as 2 pi by 3. X is equal to 2 pi by 3 implies again b is equal to 1. B is equal to 1. How? Yes, sir. Again, B becomes this one, and again it syncs with the value B is equal to 1. B is equal to minus 1. Very important here. B is equal to, because this value have 0 minus 1. So B equal to becomes minus 1. Very important. B becomes minus 1. Therefore, sine of 2 pi by 3 is equal to minus 1. Definition. Next, again, for x is equal to 2 pi. X is equal to 2 pi or minus pi implies b is equal to again 0. Yes, sir. See, b here is there. Again, b becomes here minus b becomes minus b becomes minus b. Here this becomes, okay, at this point b becomes 0. It's circulating. Therefore, sine of 2 pi or sine of minus pi. You can tell? No. If you are not defining this space, that will be, then b is equal to 0. Sine x is equal to, sine 0 is equal to 0, sine pi is equal to 1, sine pi is equal to 0, sine 3 pi, yeah? This is 3 pi, okay? Just 3 pi by 2. This is 3 pi by 2. Pi by 2. See, let's consider the value for the cos x. Similar value for the cos x. You can tell sine 0 is equal to 0, sine pi by 2 is equal to 1, sine 3 pi by 2 is equal to, next value is sine pi. Sine pi is equal to 0. Yes. Sine 3 pi by 2 is equal to minus 1, and sine 2 pi is equal to 0. That's why this is called circular function. Okay. That's why, see, this is the end. So the period is, this period is 0 to this period is CC from minus 1 to 1. So maximum value is 1, minimum is minus 1. Yes, sir. Maximum value is 1. This is the maximum value is 1. Okay, sir. This is the maximum value is 1, and minimum value is minus 1. Minus 1 plus 1. That's why this swings periods in between 1 and minus 1. That's why it's called periodic function, the circular function. Circular function. See, here the value of b becomes here. See, b becomes here. Okay, b is here. Again becomes down, becomes 0. Again increases downside, reaches maximum, minimum, minus 1. Again comes back to the, yes sir. Again comes, okay, this is the circle, okay, this is the circle, b value. Okay. Let's see for the same as for the cos x. Okay students, next same function for the cos x. This is the circular function of unit circle. Okay, so this is 0, this is a, 0 1 0, this is 1 0, this is x, this is x dash, this is y, this is y dash. Okay. This is b, value is x is 0, a is 0, b is 1. This is c, a is minus 1, b is 0. This is d, a is 0, b is minus 1. This is the 0 degree, or this is the pi by 2. This is the pi by 2. This is the pi. This is 3 pi by 2. This is 2 pi. 0 or 2 pi. So let's check for the cos values of x. Cosine values of x. Cos x is equal to a. Our definition for x belongs to all real number. At x equal to 0, at x equal to 0, this is the point P, A and B, means I am taking this one. This is the point A, and this is the point B, means this is the B, parallel in point B. At x equal to 0, at x equal to 0, so what is the value of A? See here, quite difficult to imagine here how to make this one. So B, you can do it. So B, here you can do something else. For A, what you will do? X equal to 0. X equal to 0. See, this A becomes 1. See, this becomes completely, this collides with this one, syncs with this one, overlaps with this one. For this one, see, here how should I tell? See, this is the, this is the x, and this is the one angle, this is the A, this is the B, this is the second angle, this is the A, the B, this is the third angle, this is the fourth angle, this is the fourth line, fifth line, sixth line. For this, it becomes, see sir, if become decreasing, if become decreasing, this one, this side, see, this is the 1 unit, this is the 1 unit, this is becoming, becoming, see here, this the become B, becomes small. So this overlaps with the C. What is our concept? Cos x is equal to, cos x is equal to A. Imply that x is equal to 0, implies that A is equal to 1. Therefore, cos 0, cosine 0 or cos 0 is equal to 1. Next, let's see for the next pi by 2. At x is equal to pi by 2. Then A is equal to C. Here I should understand C. This is the A for small. Look at that. This is the unit circle. So this is the A. Again this becomes A. And again this becomes C. Again not possible. This is the A. Power value. This is the 1. This is B. This is A. This is A. So this is 1. This is B. This is A. This becomes, this is coming. This is B. This is A. This is 1. This is B. this is almost 0. A is equal to 1. So is there A is less than 1. A is less than 1. A is less than 1. You should imagine in this angle, sir. Okay, small angles. Okay, see, the B is maximum. B is coming down. Okay, sir. How did the value 0? Okay, sir. This is the 0 towards 0. Okay, sir. This is the value towards 0. From 92 towards 0. How this side hypotenuse coming towards, bending towards 0. Okay, sir. This B length becomes 0 and A length. Okay, sir. This A length increasing up to single unit digit, unit number. That's why for pi by 2, yes, sir. For pi by 2, this A becomes, okay, sir. This A becomes C. For pi by 2, this is 0 increasing. So this is 0, this is 10, this is 20, this is 30, this is 40. And then this is A is decreasing, B is increasing. Therefore, A becomes 1 here, 0 here. This A, this is A, this is A, this is A. At pi by 2, this A is points in 0. Therefore, cos pi by 2 is equal to 0. Very important. How to define? Similarly, for x is equal to pi. Okay. Here, see, this is the positive direction, the opposite side. A becomes minus 1. A becomes minus 1. Therefore, cos pi is equal to minus 1. Similarly, for cos 3 pi. Cos 3 pi by 2. For x is equal to 3 pi by, for x is equal to 3 pi by 2, A becomes 0. Again opposite to the pi by 2. So this becomes 0. So cos 2 pi again becomes x is equal to 2 pi, then A becomes 1. Same is like 0, as it is 0, therefore this becomes 1. Okay, so let's see. Cos 0 is equal to 1, cos pi by 2 is equal to 0, cos pi is equal to minus 1, cos 3 pi by 2 is equal to 0, and cos 2 pi is equal to 1. This is circulating again. Therefore, the value this is also small to positive 1. Okay, sir. The value is swings between. Okay, sir. The value is swings between. Okay, sir. This is the value of cos x. This is the positive 1 and this is the negative 1. Negative 1. Okay. This is the sine is moving in this direction and cos is moving in this direction. Yes, sir. Okay. This is the cos moves from this one, this side. Sine moves from this side. Okay, or you can tell something else. Okay, this side, sine theta. Therefore, this is called circular function. That's why it appears in between the fixed number, fixed real numbers. It's called circular function or circular periodic function. Circular function. The value of the cos is also from minus 1 to plus 1. This is the brief introduction. Next, let's see the some fundamental concept on here. The values of the various angles. Value of the sine and cosine values. What we studied, sin 0 is equal to 0, sin pi by 2 is equal to 1, sin pi is equal to 0, sin 3 pi by 2 is equal to minus 1, sin 2 pi is equal to 0. Like that. Just to see here, 1 and 3, this one. Therefore, sin value is, okay sir, sin of x, sin of 0 is equal to sin of pi is equal to sin of 2 pi is equal to 0. This is the function behavior at 0 pi 2 pi. So this is generalization, sin n times pi. Okay, sir. This is the one, 1 pi 2 pi is equal to 0, or sin x is equal to 0 for x belongs to n pi. Any values of n. N is the integral multiple. Okay sir. N is integral multiple of real number or number. N is equal belongs to any integer. It's not a whole number. Okay sir. Negative also there, no? But we have not seen negative numbers, na? This is also true for sin. Okay sir, this is also I am writing. This is sin of 0 is equal to sin of, okay sir, minus pi is equal to sin of minus 2 pi is equal to also 0. Therefore, sin of 0 is equal to sin of plus or minus pi is equal to sin of plus or minus 2 pi is equal to 0. That's why this is the general formula. X is equal to, okay, x belongs to n pi and n is the any integer value. Same for negative also. Similarly for the cosine rule, take the cos theta. For cos 0 is equal to 1, cos pi by 2 is equal to 0, cos pi is equal to 0, cos 3 pi by 2 is equal to minus 1 is 0, cos 2 pi is equal to 1. Here, similarly, this is also true for these values are true for cos of minus 2 pi 0 is equal to 1. 1 cos of minus 2 pi is equal to 1. 0. Minus 2 pi means is which one? Opposite, 3 pi by 2. Nothing but this is pi by 2, this is minus pi by 2, this is pi, this is minus pi. Same circle, okay sir, not different opposite direction, that's why. Cos, okay sir, minus pi is equal to 0. Minus pi means this is 1. Okay sir, 0. Okay. cos minus 5 is 0. Cos minus 3 pi by 2 is equal to 0. This is 3 pi by 2. This is also called minus 3 pi by 2 circular. Then cos is the opposite side 0 is equal to minus 1 or 1. This is the end only. See, consider our values at odd numbers. This is odd numbers. Cos pi by 2 is equal to cos 3 pi by 2. This is equal to cos minus pi by 2 is equal to cos minus 3 pi by 2 is equal to 0. Therefore, or the odd multiple. Odd multiple. So this is therefore cos of x is equal to 0 for all x belongs to 2n plus 1 into pi by 2 for n belongs to any integer value. Yes, sir. Next sum. Next sum. We get the function. What is the other trigonometric function? The circular function means in terms of sine and cosine. Let's check the behavior of the cos at 0. So at odd angles, and behavior of the sine at integral numbers is 0. Then you know cosine x, okay sir, cosec x or cosine x is equal to cosec x is equal to 1 over sin x. Okay sir, for all not equal to not belongs to nx and x belongs to r. Because why it not belongs to means 1 by 0 is, okay sir, n pi. This is n pi because 1 by sin pi. Okay sir, if x is equal to n pi, then cos of n pi becomes 1 by sin n pi. This is 1 by 0, which is infinite, not defined. Similarly, second x is equal to 1 over cos x, and x is not belongs to 2n plus 1 into pi by 2, and x belongs to r and n belongs to any integer number. Next, tan x is equal to, the ratio of the tan x is ratio function. Tan x or cot x. Okay? Tan x is equal to sin x divided by cos x for x belongs to r and x does not belongs to n plus 2n plus 1 multiple of pi by 2, and is a number. Cot x is equal to cosecant x, cosine x by sin x. Okay, x belongs to r and x does not belongs to n pi and n belongs to z. Any positive integers. Some various sin is equal to 1 by cos x and 1 by cos x is equal to sin x. They given something else, sir. Anyway, before going to the problems area, let's prove some fundamental entities. Okay, sir. Let's prove from fundamental theorems, fundamental formulas in the cos x and sin x. In unit circle you all know already. Unit circle, the radius is 1 centimeter, and by applying the distance formula, okay, in unit circle, this is the unit circle. Okay, let's draw the unit circle here. So this is the point P, A and B. This is the origin 0, 0. Okay. This is the A, 1, 0. Okay. This is the angle. Okay. This is the R is equal to 1. By distance formula, okay, sir. Distance formula 1 is equal to, what is the distance formula? D is equal to square root of x2 minus x1 whole square plus, okay, sir, y2 minus y1 whole square. The distance between any two points in the Cartesian coordinate, Cartesian plane. This becomes 1 becomes square root of what is a minus 0 whole square plus b minus 0 whole square. In the case of this becomes square root of a square plus b square, and again taking the squaring on both sides, 1 becomes a square plus b square. This means a square plus b square is equal to 1. This is called Pythagorean's theorem in the trigonometric function or in circular function. This is the Pythagorean theorem in the trigonometric function of circular function. Simple here. What is the value? Is the cos x, cosecant square x plus sin square x is equal to 1. This is the fundamental first concept. Okay, first identities. Okay, for all x belongs to R. First identities. So here we can do interchange. Sin square x is equal to 1 minus cos square, or cos square is equal to 1 minus sin square. Okay, just again second one is just divide the a square by b square plus b square by b square is equal to 1 by b square. Dividing b square on both sides. What we will get? This is cos square x divided by sin square x plus 1 is equal to 1 by sin square x. 1 by sin square x. This implies, see here reciprocal, okay, denominator sin x is there, therefore x is not belongs to n into pi. Therefore next formula becomes cos theta by sin theta is equal to cot square. Okay, so cot square x plus 1 is equal to cosecant x. Cosecant square x. This is the second. Similarly, for third, divide the cos square on both sides. A square plus b square is equal to 1. A square by a square. B square by a square is equal to 1 by a square. A square will cancel. 1 plus b square by sin square x by cos square x is equal to 1 by cos square x. Okay. Here okay, the denominator is cos square, therefore x does not belongs to 2n plus 1 into multiple by 2. Okay, this implies that 1 plus tan square is equal to secant square x. This is the 3. These 3 are very important identities, fundamental identities in the circular function. Okay, the last concept is opposite functions. Okay, sir. Opposite functions. Last concept is there. Okay. First quadrant, second quadrant, third quadrant, fourth quadrant. Then the value of the quadrant here, sine values and cos values in the different quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. Okay, this is the y, this is the y dash, this is the x, this is the x dash, this is 0 1, this is 1 0. So this is okay, sir. I am taking 0 1. This is -1 0 and 0 -1. So any point here P is equal to A into B. Here, sir, any point P is equal to, sir, A is negative here and B is positive, and any point here P is equal to A is negative and B also negative, both. Okay, sir. This is also negative and this is also negative. And fourth quadrant, okay, sir, any point A is positive, B is negative. This is the fundamental. If you understand this one, where is the A, where is the B, you will get the value of sin x and cos x with respect to first quadrant. First quadrant, here, this I can write, okay, sir, this I can write cos x into sin x. So here, cos of minus x, okay, sir, cos of minus x, sin of x, okay, sir. This is the negative value, na? Yes, sir. This angle is negative, okay, sir. Cos x is minus x. Then see this how cos becomes positive here. And this is the important concept here. How the cos becomes positive here. Okay, this is not minus x. Yeah. This is the cos value is minus cos x. Yeah. Similarly, here both value you will get minus cos x and minus sin x, and here you will get cos x and minus sin x. Cos x and minus x. This is the different values in the different quadrants. According to the angles. And next one is the negative angle. Next one is a negative angle. Negative angle measure. This is the unit circle. This is the unit circle. This is the positive. This is the negative. This is the P. Which one? A and B. This is the X, and this is the Q. See, A is the positive and minus C is minus B. This is called negative value. How see? This is the value of the X here. Here sin x is equal to B and cos of x is equal to A, where for x is for x positive. Here sin of x is equal to minus B. This is sin of minus x is equal to minus B. Yes, sir. Sin of x is equal to minus B. Yes, sir. This is sin of x is equal to minus B. What is the value of B? This is what, okay, B is equal to sin x. Therefore, this becomes minus sin x. This is very important, sir. Sin of minus x is equal to minus B. In that this concept, okay, sir, because this is cos x, this is minus sin x. Therefore, negative value of the minus sin x is equal to minus B. Similarly, for cos x is equal to cos of minus x is equal to, see, the cos x is positive is equal to A na, for this concept. So this becomes cos x because A is equal to cos x. Therefore, sin of minus x is equal to minus sin x, and cos of minus x is equal to, okay sir, positive cos x. Very important. These two are very important. Similarly, okay sir, for C, cosec of minus x is equal to minus cosecant x, because this is the reciprocal of sin theta. Sec of minus x is equal to secant x. Okay sir. Tan of minus x is equal to sin of minus x divided by cos of minus x is equal to minus sin x divided by cos x. Therefore, tan of minus x is equal to minus tan x. Similarly, cot of minus x is equal to cos of minus x divided by sin of minus x is equal to cos x divided by sin x minus sin x. This becomes minus cot x. Sorry for the fast handwriting and inconvenience. These are the, okay sir, negative values of the angle. Okay sir, negative angles value. Okay. So this is the theoretical part of the circular function. So next class we will discuss about the problems, questions based on the completely problems only. Okay sir. Let us see sir. Okay. Sorry for this fast handwriting. This is only our thing is cos of minus x is equal to a, positive a. This is the positive direction. First, okay sir. Fourth quadrant. That's why cos x. So cos of minus is equal to cos x, sin of minus is equal to minus sin x, because this is the reflection point. Q is the reflection point of the A with reference to the positive A. Okay, fine. Okay, students. This is the conclusion. We will meet in the next class, problem section in this class. Thank you. Thank you very much.